For those who still have the courage to open this last lecture video, I will give you some extra problems. I already mentioned that we would come back to problems in height and distance. So here I will explain you some terminology and then give you some problem statement, and then you can try to solve those by next time. This kind of problems will be encountered in real life and can be solved using trigonometry. To solve this, we have to know what is an angle of elevation or an angle of depression. An angle of elevation is the angle that you obtain when you look upwards, so when your line of sight moves up and you measure the angle always from the horizontal plane, which most often will be just the ground level. The angle of depression is the exact opposite. You are on a height and basically you are looking down, so you are looking towards something that is below you. So the angle of depression is an angle formed by the horizontal plane to your line of sight, but it will be a negative angle, it will be an angle downward. Assume for the first problem that you are flying in a plane and you are looking downwards and you see that there are two consecutive milestones and the angles of depression that you see are 45 degrees and 60 degrees. Use this information to find the distance of the plane from the ground. To solve such problems, you will always first make a sketch. It will visualize your problem and it will help you see what you know and what you have to find. So what do we know in this case? You know that you are in a plane and the plane is flying over a straight road. Down on the road you see two milestones. And for these you know that the angles of depression are 45 degrees and 60 degrees. What you now need to find is the height h of the plane. We thus know that this one is a straight angle. This angle, so from the green to the yellow line, is also 45 degrees because the blue and the yellow line form an angle of 90 degrees. We then also know that this one is 45 degrees. Similarly, you can see that this one is 60 degrees. This angle is 30 degrees and so on. So you make your sketch, you indicate everything that you know, and then you will see what can I use to find the thing that I'm looking for. So in this case, what can I use to find the value of h? To facilitate writing, let us also give some names to the different points. So call this O from the origin, the point where everything starts. This one is R, Q, and P. From the sketch, we now see that the height h is equal to the distance OR and also equal to the distance PR. Why is this? This is because the yellow triangle is an isosceles triangle. You see that the angles are both 45 degrees and so the sides have to be the same. So the side OR and the side RP have the same length and both of them are equal to h. From the sketch, we also see that the distance QR is equal to h times the tangent of 30 degrees. So h divided by the square root of 3. And we also know that the distance PR is the distance PQ plus the distance QR. Now the distance PQ I did not indicate yet, but we know that this distance is 1 because they are consecutive milestones. So between two consecutive milestones there is always 1 mile. So this is 1 plus h divided by the square root of 3. We also know that PR is equal to h, so this is also equal to h. And then if we solve this, we get that h is equal to 1 plus h over the square root of 3. Then we have to bring h to one side, so it's h times 1 minus 1 divided square root of 3 equal to 1. So h times square root of 3 minus 1 divided by the square root of 3 is 1. Or h is the square root of 3 divided by the square root of 3 minus 1 miles. Now try to solve the following problems on your own by next time. Problem 2. Find the height of a town if it is found that on walking towards it along the ground, the angular elevation of its top changes from 30 degrees to 60 degrees. The man is walking 80 meters towards the town. Problem 3. A man lies on a road and observes that a temple and a flagstaff on top of the temple subtend equal angles at his eye. If the height of the temple is 10 meters and that of the flagstaff is 20 meters, find the subtended angles and also find the distance between the temple and the man. Problem 4. A man on a cliff observes a ship at an angle of depression of 30 degrees. The ship approaches the shore just beneath him. If he looks back 3 minutes later, the ship has an angle of depression of 60 degrees. How soon will the ship reach the shore? So try to solve these three problems using the properties of right-angled triangles, and then we will come back to those at the beginning of the next class.